Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 6. This is Section 13.4, Problem number 6. It says, draw the graph of the following function. Be sure to label the x and y coordinates of any critical points. And the function we have to graph is f of x equals 2x squared minus 4x plus 11. So again, to get the graph, we have a 7-step process. Step 1 is take the first derivative. So we're going to go f prime of x equals the 2x squared. When we take the derivative, we'll make a 4x to the first. Again, the reason being the exponent of 2 comes down times the number in front, which is also 2. 2 times 2 is 4. You reduce the exponent by 1. It goes from the second power down to the first power. The next piece, the minus 4x, will have a derivative of just simply minus 4. And again, the reason being, when you take the derivative of something with an x to the first, the answer is just the number in front of the x, which is minus 4. Again, be sure to include the sign, not just the number. The 11 on the end has no x with it, so its derivative is 0. So for the answer to step 1, the first derivative is f prime of x equals 4x minus 4. Step 2, set it equal to 0. And again, the reason for that is we want to see where the slope is 0, or we're going to have a horizontal tangent line. Step 3, solve for x. So to solve for x, 4x minus 4 equals 0. I'll take the minus 4, move it to the right side of the equal sign. I'll have 4x equals 4. Divide out the 4 in front of the x. I'll have x equals 4 over 4, which reduces nicely to positive 1. So that's telling me I have a critical point, or a point with a horizontal tangent line with an x coordinate of 1. Now, that means somewhere in line with x equals 1, I'm going to have that critical point. What I have to do next is find the height. Is that critical point happening at a height of 4, a height of 2, a height of down 2? So to find that out, I'm going to take my answer of x equals 1, plug it back into f of x, again, not f prime of x, f of x, and find the height that goes with the 1. So I'm going to get f of 1 equals 2 times x squared will be 2 times 1 squared minus 4 times x becomes 4 times 1 plus 11. Do the math. 1 squared, 1 times 1 is 1, times the 2 in front will be 2. Minus 4 times 1 is minus 4. Again, pay attention to the sign. Positive 11. So 2 plus 11 more is 13. 13 minus 4 is positive 9. So my critical point has an x coordinate of 1 and a y coordinate of 9. Positive 1, positive 9. So the next step, which is step 5, is take that point of 1 for x, 9 for y, and plot it on the graph. So I go over 1, up 9, like that. Now, that's going to be a critical point, or a point where my graph is flattening out. So it could be a maximum where the graph comes up, flattens out, and goes down, or it could be a minimum where the graph comes down, flattens out, and goes back up. So to figure that out, I want to find the height a little to the left and a little to the right of my critical point. So I'm going to have my critical point occurring at x equals 1. I'm going to put in an x of 0 and an x of positive 2 and see if the heights are a little above or a little below that point. Let me start with the 0 because that plugs in really easily. Again, into f of x. F of 0 equals 2 times x squared will be 2 times 0 squared. Minus 4 times x will be 4 times 0 plus 11. The math for this is easy enough. The 0 squared is 0 times 2 in front, 0. Minus 4 times 0 is 0. What's left is the 11. So if I put in an x of 0, the height I get is 11. Right there. Put in a positive 2. Go a little to the right. Go a little over to the other side. So f of 2, 2x squared will become 2 times 2 squared. Minus 4 times x will be 4 times 2. Plus 11 more. Do the math. 2 squared is 4 times the 2 in front is 8. Then negative 4 times 2 is minus 8. Plus 11. So basically I can just say the positive 8 and negative 8 can cancel each other out. You're left with 11. So if I put in an x of 2, the y I get out would be 11. And now the last step, step 7, I'm going to connect the dots. So I'm going to come down through 0, 11, flatten out at 1.9, turn around, come back up through 2.11, and both ends go up forever. That's the graph.